In this video, we're going to look at operations and composition of functions. So let's first look at operations. When you have f plus g and x, that means f of x plus g of x. Both f of x and g of x are functions. When you have f minus g and then x, that means f of x minus g of x. This means product, so f of x times g of x. And this is a quotient, which means f of x over g of x, where g of x cannot equal to 0. So we have f of x, g of x, and h of x. And they want us to find f plus g of x. This is the same thing as f of x plus g of x. So what is f of x? That's x squared plus 4x. Then plus, what is our g of x? Radical x plus 2. So that is f of x plus g of x. Now, what will be the domain of f of x plus g of x? Well, look at the domain of f of x. That's a polynomial. So domain of polynomial is all real numbers, negative infinity to infinity. Because you could plug in any x value and you could still get the y values. What about radical x plus 2? Well, in order for this to be a real number, you know that the inside of radical has to be greater or equal to 0. So that happens when x is greater than equal to negative 2. So as long as this is greater or equal to negative 2, when the x value is greater or equal to negative 2, this will exist. So the domain is negative 2 to infinity. However, for this whole thing to exist, it has to be an intersection of these two. So therefore, the domain of this, f of x plus g of x, would be the intersection of these two, which is negative 2 to infinity. So that will be the domain. What about f minus h of x? This is the same thing as f of x minus h of x. So f of x is x squared plus 4x minus h of x, which is 3x minus 5. Now when you distribute the negative, you're going to get x squared plus 4x minus 3x plus 5. And then combine the like term, you get x squared plus x plus 5. Now, what will be the domain of f of x minus h of x? This is a polynomial. So domain will be all real numbers, negative infinity to infinity. And also check, f of x, what is the domain of f of x? It's a polynomial, so negative infinity to infinity. What about h of x? That is also a polynomial, so negative infinity to infinity. Therefore, the intersection of those two is negative infinity to infinity. Next, we have f times h of x, which is the same thing as f of x times h of x, which is quantity x squared plus 4x times quantity 3x minus 5. So we have to multiply this out. So you end up getting 3x cubed minus 5x squared plus 12x squared minus 20x. Add up the like terms, you're going to get 3x cubed plus 7x squared minus 20x. Now, what will be the domain of this polynomial? Since it's a polynomial, you could put any values of x, and then you still get the y value. So domain is negative infinity to infinity. And notice, you multiply two polynomials. So domain of that is negative infinity to infinity. Also, this one is negative infinity to infinity. Therefore, you will get negative infinity to infinity. Now let's take a look at h over f, or h divided by f of x. This is the same thing as h of x over f of x, which is 3x minus 5 over x squared plus 4x. And what about the domain of this? Well, the domain is, you need to worry about when the denominator goes to 0. So the denominator goes to 0 when x squared plus 4x is equal to 0. So take out the common factor and set it equal to 0. So you end up getting x equals 0 or x equals negative 4. So domain is all real number except x equals 0, x equals negative 4. So how would you write that? It would be negative infinity to negative 4, and then negative 4 to 0, and then 0 to infinity. This is how you use interval of notation to describe all real numbers except at x equals negative 4 and x equals 0. Next, we'll look at composition of functions. Composition of function is like a function within a function. So we have f composition g of x, which is the same thing as f of g of x. And we'll look at some examples of composition of functions. So we have f of x and g of x, and they want you to find f composition of g, which is the same thing as f of g of x. So what you need to do is, you need to first realize that g of x is x minus 4. And instead of x, so we have f of x equals x squared plus 1. So instead of instead of x, we're going to plug in g of x. So f of g of x, which is x minus 4, that's what we need to do. So instead of x, we're replacing it with x minus 4. So you need to evaluate this, which is going to be x minus 4 times x minus 4. And you multiply this out, you're going to get x squared minus 8x plus 16 plus 1, which is x squared minus 8x plus 17. So this is f of g of x. Now we have g composition f. So this is the same thing as g of f of x. Now, what is our f of x? F of x is x squared plus 1. So in order to do g of f of x, you have to realize that g of x is x minus 4. So instead of x, we're going to substitute x squared plus 1, because we need to find g of x squared plus 1. So we end up getting x squared plus 1 minus 4, which is going to be x squared minus 3. And that's g of f of x. What about f composition g? In other words, f of g of 2. That's what it means. So let's first find out what g of 2 is. What is g of 2? G of 2 is going to be 2 minus 4, which is negative 2. So now we need to find f of negative 2, which is, instead of x, plug in negative 2. you end up getting 4 plus 1, which is 5. Therefore, f of g of 2 will be 5.